I would like to give a hint for number 6 on QM7. Forgive me, I have a cold, so it'll sound a little muffled. We have a block that accelerates down an inclined plane, and there is kinetic friction acting on the block as it slides downward. The motion is an acceleration downward, so our strategy will be to draw a force diagram followed by a component diagram, and then get the equations from the component diagram. The forces that exist on the block would include the normal force on the block by the ramp, the friction force on the block by the ramp, and the weight force on the block by the entire earth. Now we are going to draw a component diagram. Choosing the axes to be along and into the ramp, the normal force is already on an axis, the friction force is already on an axis, but the weight force can be broken down into an along component and an into component. And notice that the Pac-Man rule suggests that once we figure out this angle here is theta, then the component of the weight into the ramp will be mg cosine theta, since theta is chalked. Since the acceleration is down the ramp, we can write F net equals ma along the direction of the ramp. The net force would include the component of the weight down the ramp minus the friction up the ramp. And of course that's equal to ma. The other equation that we can get is recognizing that the normal force must always balance the component of the weight into the ramp. Here we have two equations, one here and one here, and two unknowns, but the unknowns are rather different compared to the normal approach of the ramp problem. The unknowns in this problem are the mass and mu. So we have two unknowns with mass and mu in it, and you solve with the two equations. I hope this hint helps. Actually, there are three unknowns, it appears, m, mu, and n, in two equations. But if one substitutes the value for n from the second equation into the first equation, one notes that each term on the left-hand side is multiplied by m, and the one term on the right-hand side is multiplied by m. And so the masses cancel. We've gotten rid of the n, and now we have one equation with mu, and all the other values are known. I hope this helps.